Okay, I'm going to start recording now. So this is the fourth week in Business Finance, FINC 19011. And we're recording, so if you do feel a bit uncomfortable having your face on the internet, or you feel inclined to make some sort of inflammatory statement, just keep that in mind, that it's going to be all there for the world to see shortly. Okay, let's move on now. What we're going to be doing today is more numbers. I hope you're getting to enjoy this stuff as much as I am. Odd thing about it is that when you get the feel for at least what we're doing in this class, it actually becomes very straightforward. Today, we're going to be focusing on really just more annuity calculations. Okay, we introduced the idea of annuities a couple of weeks ago. An annuity is where there is one payment at the beginning, usually cash outflow to buy something, share in a company, or maybe some other investment. It could be a jumbo jet. Okay, costs a bit of money to buy one of those things. And what you're expecting, though, is year by year to be then getting some cash inflows by way of what we call operations. Operations is the doings of operating some productive activity, a business or even a particular single asset like the jumbo jet, or a piece of real estate, or a company. And then at the end, there's another cash inflow, in other words, money coming back into your pocket when you sell the asset, the capital asset, the investment, whatever we want to call it. Okay, today we're going to be looking at a slightly different situation. We're going to be looking more specifically at debt. Debt is a strange substance. Today there is the perception that debt makes the world go round. And in the short term, that's true. It's a bit like, shall we say, heroin. Will put you in for a really good time for a while, but then you'll wake up and feel really, really bad. But while it's working for you, the old H is, attracted. I don't anyone experiment with this, by the way, because I don't think very highly of that substance, or anything, for that matter, anything with illegal chemicals. But there's an analogy there, because debt enables you to feel good economically by buying stuff that you really can't, in the same way that taking some illegal substance makes you feel good when you really shouldn't be. But then you have to pay it back. And the paying back costs more than the debt gave you. And so the pleasures that you lose through paying the debt back is actually going to be greater than the pleasures you gain in the purchasing power. So you buy yourself a car on credit. That's fantastic. It might be $20,000, $50,000, $100,000, whatever it is. Let's say it's $100,000. Depending on how long it takes you and what the circumstances are of your purchase, if you lease it or something, which is really a form of borrowing, you could end up paying back $120,000, $150,000 or more $1,000 for that $100,000 motor car. And so the pleasure of owning a $100,000 motor car is sort of negated eventually by the $120,000, $150,000, $200,000 worth of repayment. That's the simple maths. You'll find that reading through the finance text, it talks about all the wonders of debt. And if you use debt cautiously, prudently, it can be very helpful. In the same way, if you play with the same chemistry as heroin's made out of, you end up with morphine, and used in the right circumstances, the right dose, for the right reasons, you end up with a tremendous advantage. You know, if you, involved in a car accident or what have you, and your leg's half cut off, nothing is nicer than when the paramedic comes along and gives you a little hit of morphine. Hopefully he'll take you to the hospital and sew your leg back on, and you'll live happily ever after. That's really good. Debt is like that as well. Used cautiously, prudently, it can be beneficial financially. It can help you become wealthier. It's always something which is going to introduce risk, because one way or another, the cost of paying back is going to be greater than the cost of the money that you borrow. So it's easy for it to get out of control. However, we live in a world which is, people have said, awash with debt. If you read your ancient history books back to, the early days before you'll notice, most of you were noticing this stuff back to about 2005, 6, 7, 8, there was an event called the Global Financial Crisis, GFC. For those of us who have lived through it, the GFC was the result of a world that had become intoxicated on debt. And suddenly the banker came knocking on the door saying they'd like it back with interest. And the world's financial economy crashed. The same thing happened in 1929. And for that matter, if we go back in history, we find it also happened in 1890, 1830, something or other. And typically about once every 50 years, back to the beginnings of modernity. And these massive economic or financial collapses happening about twice a century. About every 48.5 years, if you want to be really precise, and they're known as chondriative cycles. Largely, they're precipitated by a society that has spent maybe 25 years forgetting how bad debt is, and then another 25 years or so getting into the bad habit of relying on it too much, a bit like somebody who was given a shot of morphine because their leg was broken and then ended up with a heroin habit. Not very pleasant. And eventually the whole thing fails in the same way that people who do illicit drugs find their life comes crashing down. Very ugly. Okay, so I'm just basically giving a little bit of an introduction, if you like, to the advantages but also the risks in debt. Later on, when we do topics when we start to look at risk in more detail, say with the capital asset pricing model, we'll be saying a little bit more about what debt does to risk. And a lot of people are seduced, really, by the attractions of debt. And they see the upside. And sometimes, probably most of the time, it works. But the problem is that if you use debt imprudently, it can sting big time. And in fact, it's curious that it was only at about the same time that the banking world, the financial world, had its first major era of deregulation. This is about 150, 170 years ago, middle of the 19th century, the 1800s. It was curious that when debt was unleashed, communities such as England, say in the English tradition, recognized the need to give people an escape hatch. We now refer to it as the bankruptcy laws. There was a debtor's prison before, but then the bankruptcy provisions were introduced largely on the back of the deregulation, or a form of deregulation, of the financial industry. Banks were able to lend whatever they want in whatever conditions they wanted. And that's fantastic. But what they were seeing is people just going to the wall all over the place from time to time, not all the time. And maybe not all the people. Some people won, but some people failed big time. We think of bankruptcy, it's certainly an ugly and humiliating thing to have to happen to somebody, as something which is, came out of the ark. It's something that is as old as the hills. Well, in fact, it isn't. People did ruin themselves in business before that, but in terms of it being an institution, and certainly having laws institutionalized around it, it is only less than 2 centuries old. It's coincidental, by the way, that the Great Potato Famine in Ireland, excuse me, Great Potato Famine in Ireland was partly the result of the failure of the potato crop. A particular bug, bacteria, got into the potatoes and caused them all to wither up. But the main thing that caused the potato famine, the impoverishment, the widespread famine and death of huge numbers of people in Ireland was the result of debt. Turns out that the English landlords had borrowed themselves up to the hilt so they could maintain their lifestyle in England, and they were relying on the cash flows that came from their Irish land possessions. And when the Irish farmers found that their crops had failed, they couldn't pay the rent, the landlord said, well, yep, that's your problem. We're just going to take all your food. And they did. And there are stories of the starving to death Irish farmers watching as English soldiers took away the remaining food from their country to sell in England and pay off the debt of the landlords. Caused a huge percentage of the population of that country to either die or emigrate because you couldn't live there. All the result of debt. It's a hugely important thing and worth taking very seriously and very soberly. It is no coincidence that in the Islamic world, at least those parts of the Islamic world that take Islamic law, Sharia law, seriously, the charging of interest on a money debt is considered immoral and in many cases illegal. It's referred to as riba. And it's considered to be a very ugly thing. Arab Bank and other financial institutions within the Islamic world have worked out ways of providing finance and being financial intermediaries without charging interest. And that's an interesting study in itself. It's no coincidence, by the way, that during the GFC, the global financial crisis, now about a dozen years ago, a bit more, the Islamic financial system was the only part of the global financial system that did not fail. And it's largely because when the Islamic financial system is working, as it is meant to work according to the prohibition, the immorality of riba, it's basically bulletproof. You don't have bankruptcy, you don't have financial failure. Okay, that's all interesting background stuff, and it's really intended to give us, if you like, an introduction into what we're going to be doing today. Okay, now I hope that everybody has a view of my screen, so less of my pretty face to see, and we'll start to go through these slides. Some basics on debt. I'll get you to read these in your own time. The really important thing here as we go through is to look at the way that common debt works. There are going to be two types of debt that we're going to look at. One is a term loan, and we're going to be doing an example on the way that the mathematics of term loan uses. And then the second part, we're going to be looking at bonds. Can't see the slides. Uh-oh.
No, I can't see the screen sharing either.
Rats. Thank you very much. Is that better?
Yep, got you now.
Fantastic. Okie dokie. Okay, we're going to be looking at term loans. Okay. This is something which is fairly close to most people's experience. You'll have either yourself or maybe your parents or some close relative who has borrowed money to buy a house. Not uncommon. The great majority of people in Australia who own or say they own their own homes actually kind of own it, half, because the bank probably owns more of it than they do. And the type of loan that they use is a loan which extends them the funds to buy their house. They make a regular payment. In the case of house loans, it's usually monthly. It can be other intervals up to annually, but monthly is pretty typical. And each month, each period, interest is charged on the loan, and a payment is taken. And so the payment is made up partly of the interest and partly of the principal. And now we're introducing a few terms. Okay, the principal is the amount borrowed in a loan. We talk about the interest cost and then also the repayment. Okay, the repayment. So I've got principal, repayment, interest as the parts, if you like, of this. We can usually model these, well, you can model them a couple of ways. We're going to demonstrate modeling them in what I consider to be the kind of more bulletproof, but perhaps old-fashioned way, but also the more illustrative of what's going on. And we have a bit of fun with that. For those of you who are going on to do property investment and finance, we actually sort of take this topic a bit further and you build a really fun kind of little model that enables you to do all sorts of wonderful things with property mortgages. Okay, but for our purposes, we're just going to basically introduce this idea. Now, again, this is more interesting, I think, to read than to have me prattle on with. And so I will let you read those in your own time. Another term that we need to be familiar with is the idea of amortization. Mort comes from the Latin for death. To amortize something is to kill it. And so you're aiming to kill the loan over a period of time. So home loans, for instance, typically 25 or 30 years. And so the loan is killed over that time. It's amortized over that time. And the idea there is that at the end of the loan period, after paying back these regular payments month by month, there's nothing left in the loan, so you're free. And in the case of property, that's pretty exciting because you actually get full title to your land and all that sort of stuff. For a lot of people, that happens about 6 months before they retire. Okay, how does it work? I'm not going to go too far. We can say you can work through the slides here, and I'd like you to do that. I'll give you a couple of demonstrations of parts of it, and I think that's probably about the best use of our time. That's what I'm going to do here. I'll just put that aside for a moment, and I'm going to come up. I'm going to give you some demonstrations with Excel. Those of you who have, watching this or following this on a laptop or have a computer nearby, good idea for you to fire up Excel, or maybe open up your OpenOffice package and open up a spreadsheet in that, or any other spreadsheet that you have, Google Docs, whatever. But if you tap along with me, then you can sort of see this taking shape as we go. Okay, I'm purposely going to build this just pretty much off the seat of my pants because I want you to see the common sense of this. We can give you a fancy model, and as I say, in the subsequent unit, for some of you who are going on to do property investment and finance, you'll be doing this in great detail. Here, what I want you to do is just get what I think of as common sense basics. Let's say we're going to start off, and I'm just going to start off here. We're going to say principal. And let's say that's $100,000, and we'll format that to dollars and cents. Okay, probably don't need to put the dollar signs in, so I tend to I like the comments because it makes it a little tiny bit easier to read. I'm going to do a little bit of fancy formatting here to make the heading stand out a little tiny bit. Okay, over here I'm going to say period. And I'm going to start with period naught. So this is day one, or in fact day naught, really. This is when I go up to the bank, have a little bit of a chat. They write me a check or squirt a whole lot of money into my bank account, or however the transfer is made. But at the very beginning of the game, that's when I get the benefit of $100,000 to spend. And usually that's exactly what I do with it. if you borrow $100,000 or $1 million or $10 million, usually you don't do it so you have a little pile of cash kind of sitting by the front door, show off to your friends. Usually, especially when you're borrowing a fair bit of money, you spend it. You actually get rid of it. It goes, disappears. I don't think I've seen very many people who have borrowed a large sum of money and actually have it lying around the house. Maybe you have. Okay, period naught, the very beginning of the game, we get the money, and as I say, that money then actually disappears as a physical quantity or purchasing power in your pocket, because you actually go off and buy something with it. Maybe I should do this with $1 million to make it a little bit more interesting, but we'll do it with 100,000. Okay. We'll say that the interest rate is, think of a number. Now, realistically, in our world at the moment, and we'll use a home mortgage kind of world, 3 or 4%. We'll say 4%. Okay. Now, what we're going to do is now we're going to come down to the first month. The first month. Work out what the interest cost is. Notice that we've got the interest rate here, which is our 4%. And we have the interest cost, which is actually a dollar amount. The dollar amount, no interest cost in the first month, but there's no interest cost, as you buy the loan, you take the loan. But after a month, what's happened? What's happened is that you have had the principal for the previous period, so I'll just grab that, in this case is F7, and we're going to be multiplying that by the interest rate. I'm going to absolute that by hitting the F4 key, or I can just write in B2 with dollar signs before the B and the 2. That makes it absolute. I'm going to divide that by 12. Actually, no, I'll even write down, I'll put 12 in there so it's really obvious. And I'll close the brackets. And it really wants to see the number 12 in there. Okay. Frequency, and we've been seeing that as M, and so we'll put that in. So it's 12 times per year. We could say monthly, really, but this way I can change it. I can make it twice a year, so I might be having 2 payments per year. In which case, if I do 2 payments per year, $100,000 with a 4% interest rate, the interest cost after 6 months is $2,000. But we'll go back to monthly. The nice thing about working with Excel, you'll notice that I'm putting in my data, and then I write equations. I don't write many equations in cells where what's inside here are numbers. You notice the interest rate isn't there? It's a cell address. The recurrence interval, it's a cell address, and so on. Okay, I don't write numbers. Okay, I don't say, $100,000, whatever. And the reason for that is that if you get in the habit of writing your Excel equations like that, it gives you the power to be able to change the interest rate, right? So if we do that, now we're able to change the interest cost per month really, really quickly. I just recommend that you, as you get your Excel skill, 47%. Now that's the kind of interest rate that, was around, before they started, especially in the United States, the usury laws and stuff. And that's the sort of stuff that gave us a lot of bankruptcy in times gone by. Okay. Right. Now, as well as that, we're going to make a monthly payment. Let's put payment. Here we're going to do something a little bit tricky. I'm going to use the acronym here, or the abbreviation PMT, because that also gives us a bit of an idea of what the Excel function is. Just going to rearrange things a little bit. I'm going to insert a row here. I'm going to put another variable or parameter in here, which is going to be the term. How long does the loan go for? Here I'm going to say 25 years. I'll just turn that red. Okay. Now it turns out that with those bits of data, especially those of you who have got a nice financial calculator, and I've got a couple of you who've got HP12Cs, and I think a couple of folks have got other varieties of financial calculator. While I'm talking, see if you can work out what the monthly payment is before I write it in. Yeah, away you go. Get into it. Okay. You can do it on Excel too if you want, but if you've got your financial calculator, now's the time to get out and press the buttons, right? Okay. The other bit of data you need is this one here, which is the principal. I guess that's sort of handy. And I'm going to do one other thing. You'll notice it's a habit of mine. It comes because I once did a lot of work for a company called Estate Master, and they had a convention. Your data went in as blue numbers, and your calculations went in as other colors, usually black. So you'll just notice that I tend to put my data in as blue, so I find it a nice convention. That way I can spot. You see, here's an equation because it's black. Here's a bit of data. It's blue, and away we go. You don't have to follow that, but you'll just notice that it's a habit that I use, and it might make it easier when you're trying to reverse engineer models and stuff that I've made available to you. Okay, right, payment. Okay, let's work out this payment. Okay, hopefully I've prattled on long enough that those of you who are pretty nimble with your financial calculator buttons will have worked out what the answer is. Okay, let's work this out. Excel has a nice built-in function, PMT, followed by an open bracket. And when you start with that protocol equals PMT open brackets, notice how down here Excel has put in this little hint sheet here, this little hint line. And it says, yes, I recognize the PMT function, and I'm expecting the first parameter to be the rate. The rate I'm going to take from there. So I've just clicked on the cell. That picks out that number. However, I'm not really interested directly in the interest rate, am I? Because I'm looking at not the annual interest rate, but the monthly interest rate. So I'm going to divide by the frequency, and that's the rate now, monthly. I put a comma in after my parameter. Excel recognizes then that's the package, the mathematical expression, which is in there before the comma, is telling Excel this is the equation which needs to be solved in order to inject the parameter for this particular Excel function. Okay, parameters, if you like, are the data. Okay, I've got the rate done. I've got that, and as soon as I click the comma in there, down here, my little cheat row here, it's come to this next one, which is N per. That's a really weird acronym. It stands for number of periods. Okay, now I've got 25 years as my term, and so here, what I can insert is the 25 years. But hang on, it's not actually 25 periods, is it? Because every year I can do 12 calculations. So I put in the annual, then I multiply that by the recurrence interval. Okay, so it's a little equation going there. Now I'm going to put a comma in. Watch what happens somewhere down here as soon as I put the comma in. Okay, just watch that. See how N per is bold? Watch this. Now PV is bold. All right. PV is the present value. You should be familiar with that one by now. We've been talking about it for the last few weeks. Present values, future values, that sort of stuff. Okay, the present value is how much I've borrowed. Now, a nice little convention. Money coming into your pocket is positive. Money going out of your pocket is negative, normally. However, if I get PMT to come out with a negative number, it's going to look a little bit weird. Okay, yeah, sure enough, the payment is going out of my pocket. Am I going to put it in as negative or get it the thing to work it out as negative? Well, it just doesn't look good. You know, having lots of minus signs unnecessarily all over the place, and all of these are going to be minus because all of your payments are money going out of your pocket. It's kind of tidier not to bother with the minus signs. You have to remember in your head that there are minus signs there, but we're not going to trick it into giving us that convention. Okay, now how do I trick Excel into taking out the minus sign? Well, the way that these calculations work, and it's the same with your financial calculator, at least all that I'm familiar with, is that the financial calculator is giving you an answer. In this case, it'll work out the payment that balances, negates the variables in here, which is largely the PV, the present value. Okay, and if I put this in as positive, in order to negate it by giving me the regular payment over the next 25 times 12 or 300 payments, it's going to return a negative number. I don't want a negative number. So I'm going to actually put the principal in as a negative. Just watch this. I'll show you what happens if I don't put it in, but that's what you do. You put it in as negative. Last point to note, I'll come in here, I'll just leave that open before I put the closing brackets. Notice that there are two more parameters here in square brackets in my little cheat line, right? Square brackets FV, close square brackets, comma, and type within square brackets. Excel says these are optional parameters. You don't have to insert them. In certain circumstances you may want to, but typically you don't, okay? This is for the situation where your loan is written, and loans aren't normally written like this, but let's imagine that the loan was written. So they lent you $100,000 and you're paying it off over 25 years, and the last payment is going to be a big payment, I don't know, $10,000 or something, whatever. I don't know why, but it could be some big payment just to go and close the show down. Sometimes the expression balloon payment is used in connection with this kind of final payment to finish the thing off. It's not that common, and so Excel isn't expecting it. So the FV is not necessary because it's going to be zero. Right? So it's an optional parameter. In this case, we're not going to use it. Makes life easy. Okay. The other optional parameter is type. Now, type is a curious one. Type is ordinary annuity or annuity due. Ordinary annuity is that the cash flows happen at the end of every period, which is pretty much what happens in the loan. Okay, I'll borrow the money today. In a month's time, I get my first bill, or I have to make my first payment check. Right? Rent is usually an annuity due because I usually pay my rent before the week that I occupy, or the month, or whatever it is that I occupy, whatever it is, you know, drive my car if I've rented my car, or rented my house or shop or factory or whatever it is. So type is for ordinary annuity or annuity due. And again, loans are just ordinary annuities, and so we don't use anything there. So we're finished, basically. And by the time I put that bracket in, I've finished the equation. That should come up, oh my goodness, give me dollars, pounds, sorry. I have to go and change that around. Fair enough. Okay. What that's saying is that the payment is $527.84 per month. I'll just put a little bit more in here, PA, to say it's per month, and here we're going to be per month, and so that's going to fill it all in. Now down here, I'm going to simply bring that in from yonder. Okay. Now the payment is going out of my pocket. The interest case is also being taken out of my hide, in a sense. What's happening to the principal? Okay, well, it's going to form up an equation here. The equation is that the principal at the end of the first month is equal to the principal at the end of last month minus the payment plus the interest. So I didn't make any payments back. What will happen is that the cost of the whole thing that I owe, the amount that I owe, would actually sort of go up. I'll demonstrate that shortly. Okay, but by and large, what's happened at the end of this first month, I started off with $100,000. I pay back $527.84, and I end up with my loan now at the end of the first month only being outstanding by $99,805.50. I feel good because my loan is a bit smaller than it was. I feel bad because it's not $527 less than what I started off with, but it's a little bit less than. Okay, and that's the way it works. Okay, I said that I'd see what happens if I didn't pay anything back, and okay, by taking that number out, I've achieved that. And so it shows fairly transparently that if I don't make any payments, the interest cost is simply added to the principal, and so the principal, how much I have to pay the bank back, actually is increasing. Now it's one of those trucks, and the equation looks like it's right. I'm going to be a bit lazy here. I'm going to cause Excel to work out the interest costs. Now remember, the interest cost is always worked out on the previous month's principal. Right. Why are there no numbers here? It's because the equation can work out the interest in the second month because it's working out from the previous month, but there's no third month, or second month, third month, and so on, and so these things are just zero for the moment. While we're doing this, I'll copy down a few of those. This is great for lazy people, isn't it? Wouldn't it be tedious if I had to write 1, 2, 3, 4, 5, and I'm a really lazy person. So I like this because it's doing it automatically. I'm going to do the same thing over here. Grab the lower right-hand corner. I think we talked about that a week or two ago. Pull that down. And isn't that lovely? All those equations are done for me. And for a lazy bloke, it's fantastic because I've only written out how many equations here. I wrote out that equation, that equation, that equation. And all these equations are free. Whoop-de-doo. Wonderful. Okay. I'm just going to sail down here a bit. Some mysterious thing is happening here. What's going wrong? Oh, that's right. We haven't got any payment, do we? Okay. Without any payments, it's a bit embarrassing because my principal is getting up and up and up and up and up. It's actually compounding. I'm going to do a little tricky thing here just for demonstration purposes. You guys may not want to do this, but you're welcome to if you feel up to it. I am going to take these numbers, I'm going to take them down to about 310, I think we'll do it. I'm going to insert, I'm going to come over into my insert menu, and I'm going to insert a chart. I think I'll do this one. I tend to like the XY ones. And I'll do a chart that looks like that. Okay. What this is doing, it's charting what's happening to the contents of this column. Okay. And principal time, so I'll put a nice little title there. And while I'm playing with the chart, won't spend too much time on this. I'm going to say, okay, then I'm charting that. I'm also going to that. What I wanted to do was put in our period numbers as a Okay, I don't think I'll go any further with that at the moment. Yes, I will. Let's do it. There we go. Where's my chart gone? Excuse me, folks. Oh, here it is. Sorry. It's there all the time. Come on. Okay. Tiny bit tedious here. Didn't really mean to put it in such an awkward spot. There you go. Put the chart up yonder. Bring it back to full scale. That'll become a little bit interesting as we go along. Okay, what have we got? We've got the payment there, and we said the payment is being taken from the calculated payment. I'm going to make all of the payments the same. And I'm going to come down here. I'm going to do a tricky thing a bit later on. Go. I'll bring these down. I'm going to continue this down. Yeah, I'll do it about 310. So what happens here. Like you do. Now, notice something that's happening here. At the 300th payment, after we made the payment, we pay $527.84. It's $526.08 kind of sitting there outstanding. Add $1.75 of interest, and guess what? The result is $0. Okay. At that point, I'd probably stop paying my my monthly payments. So what I'm actually going to do here is add an extra little tweak here. Again, this is kind of, not, it's something not for all of you to bother with, but if those of you who are interested want to, you're most welcome. I'm going to put in a logical test, an if statement. I'm going to get it to switch off the payments once the outstanding principal has gone down to $0. Okay, so it's negative. All right, so what I'm going to do, I'm going to say if the payment from the previous period is less than 0.01, so that's 1 cent. I'm going to put in 0 for my repayment. But if it's not, another comma, we'll take the previous value, D308. I'm going to close the brackets. That sort of finishes my conditional statement there. Again, I have the little sheet line underneath that you can practice that with. And I'll put that in. You notice what happened there? By putting in that if statement, I've said if I paid off the loan last month, I'm not going to make any more payments. And what I'm going to do now, I'm going to fill that equation in down there, and that'll continue it. So regardless of how far I fill that into the future, that will remain 0. Okay. I'm going to do one other thing though. You see here I've got an equation which has got an if statement in it. Here I've got an equation which doesn't. I'm going to fill this back up here. And you'll notice it won't do anything at all to the numbers. Just watch what happens. Okay. And you'll see the $527.84 hasn't changed. But if we look at any of these equations, they all have the if statement in them. Okay, so now I've got a lovely thing which pays off my principal over time, and then stops the payments. You notice here that the chart is showing that over time my outstanding principal is following that nice, looks like a parabolic curve almost. It's not really. It's an exponential. Oh, isn't it an exponential? It's an inverted log curve, I think. Whatever it is, it's got a curve in it. I'll show you a couple of little quirky things about that curve which are worth knowing about. When I was the age of most of you guys, say in the 1970s, interest rates on loans during the 70s and 80s peaked out, well, actually got up to about 18%. 15, 18% was not uncommon for regular household mortgages. This is not borrowing money from some loan shark at the back of the pub. This is just go down to Combank or Westpac or whatever, and interest rates were quite high. I'm going to put in 12% here. I want to look at what it does to the curve, right? You're watching the chart there. Watch what happens when I hit the return key here. See how that changes? And it turns out the bigger the interest rate is, the more the bulge is in this curve. The further away from a straight line it becomes. I'll put in some absurd rate, 24%. And you see that the curve gets more arched, right? I'll come back and I'll put in 1%. It's almost a straight line. And 0%, and those of you who have kind of got a bit of mathematical shrewdness about you, well, no, of course, if there's no interest rate, all I'm doing is just paying back the loan bit by bit. There's no interest being charged, and so it will be an absolutely straight line. Okay, we're somewhere between those extremes, right? Somewhere between the humpback thing, which was, interest rates in the 70s and 80s, and the straight line, which happens in a riba-free world. Well, it's not quite that simple, but we might talk about Islamic finance another day. It's fabulously interesting. We've got 4%, we're saying, so I've got a little tiny bit of an arch in it. So that's kind of one of those things you sort of notice. That arch, by the way, becomes very important. I'll go back to the absurd one for 24%. The payments here get pretty absurd as well. But notice that when you're paying a very high interest rate, in the first month, your payment is $2,005 monthly payment. Your interest cost is $2,000, which is almost as much, right? And so you're paying just about entirely interest in your first month. When the interest rate is in our numbers, you're actually paying a fair bit more. We're just going to put in an equation, just a simple equation to illustrate how much we're actually paying back. So we're going to say that the payment minus the interest cost gives you an idea of how much you're taking off the principal. Here you're taking off $194.05. When the interest rate goes up, and I'll go again to the absurd level, you'll notice that the monthly repayment off your principal has actually fallen quite considerably. You're spending $2,005 a month. Just imagine that, $2,005 going out of your pocket every month to go and pay off your home mortgage for $100,000, $100,000, and only $5 of those dollars is actually whittling away the principal. There are kind of expressions for that, but they're not very polite, but it's pretty close to sweet. Nothing. Okay. And that's one of the things, that also one of the ugly sides of interest when it sort of bites. We're going to go back down to 4%. And now we're paying back $527 per month, and 194 of that is principal repayment. I'm going to write that up as a percentage of your repayment, right? So it's simply a matter of putting the amount taken off the principal divided by the actual payment. And so here we've got 37%, over a third of your repayment in our world, our 4% world, 3.5% world, is repaying off the principal, which makes you feel good. It's also an awful lot cheaper, isn't it? Right, I'll just duck up to the 24%. Oh dear. I have to put in a couple of extra decimal places there. 26 basis points. Okay. The nice thing about doing a model like this, if you guys get to do it, and those of you who are tapping along as I'm sort of doing this demo in class, gives you an idea of the dynamics of how debt works. This is a very powerful thing, but really the equations are very, very simple, and I hope you guys have actually been kind of fitting this in as you go along as well. We won't worry too much about that. That's not really that interesting. As it's just good to help us understand the strategy of debt. That's the only reason I've put those calculations in. The important part is these fellas here. Okay. This is called an amortization table. Lots of different ways of doing it. Okay, and you'll find that as we go through the slides. Okay, what have we got? We've got a bit of ideas going in here. We get to loan amortization. That works out the regular payment, PMT function. I think most of you will either be using Excel or a financial calculator. You can do it by hand by applying this equation, by the way, and you're most welcome to. I'm not going to sort of talk you out of it. When I first was doing finance, I used to do this for fun because I really enjoyed mathematics and I was a real masochist. And it's good if you want. I don't want to discourage you from understanding the maths, those of you who are inclined. But if you see yourself as a past credit kind of student, don't bother. Better things to do with your time. If you see yourself as a high D and really want to, get the most out of understanding all of this and the stuff that's sort of secretly going on in the background, by all means, get into the mathematics. Okay, so it's up to you. Okay, in the exam's going to be online, and the same with assignments. So you're going to have Excel available or your financial calculator. So I recommend that you just basically accommodate your learning to suit. Okay, what have we got here in this slide? We've got pretty much the same thing as what we were doing. It's laid out a slightly different way. Yeah, you'll notice that here in this slide, that number reappears down here, that number reappears down here, and so on. Sometimes it's just been doubled up for the purposes of illustration. It's a nice way of setting it out, I guess, for demonstration purposes, but really for doing a nice little tidy model, this is a little bit tidier. You've basically got one less number in there. Okay, you can go through those. So that, but I think it's more fun to build it on Excel. You can do this, by the way, with a financial calculator on a piece of paper, especially squared paper, the kind of paper that you would have used at school for your maths textbook, not your maths exercise book, the 5 mil, 6 mil, whatever they were, squares. And you can run one of these up by hand. It takes a bit of time, but some people like to do that. Okay, effective annual interest rate. We're really in this. We want to get down to, I think, this equation, or it's laid out in this form, really the effective form. Now I'm just going to show you how this works. I'll put this, how can I do that? Put that across the side. Effective annual interest rate. Here, go back to 4%. Here we've worked out the basic parameters, right? So I've got 4%, 12, 25 times a year. Now we're saying that 4% is the interest rate. Is it really the interest rate? Well, the curious thing is that because of the compounding mechanism, interest on interest, you're actually spending a bit more than 4% on your 4% loan. The banks don't like to make a big thing of that. It doesn't make a huge difference when your interest rates are relatively small. But when your interest rate gets up to those scarily high numbers, 13, 15, 18%, or the 24 that we'll be mucking about with, then the difference between the apparent rate, the stated rate, whatever you want to call it, and the real rate can hurt. So let's work out how to do that. The effective annual interest rate is worked out using this equation. 1 plus the annual rate divided by m, close brackets, raised to the n minus 1. For those of you, again, who are pretty sharp with the maths, you will find this, not necessarily for this purpose, but certainly if you did 3-unit at school, you should be able to find that when we're talking about series and stuff like that. I'll leave you to ferret that out in your own time. I'm going to add an extra row here. I'm going to put EAR, effective annual rate, and I'm going to basically put in the Excel function for this. I'm going to just basically write it in pretty much as I see. 1 plus I, the interest rate, divided by the recurrence interval, close brackets, raised to, so that's the shift 6 up arrow, the recurrence interval, minus 1. I think Excel will solve that correctly. Okay, and we'll format it as a percentage. We'll put a couple of decimal points in there, and we can see that, yeah, okay, it's 7 basis points. When we talk about basis points, we're talking about hundredths of a percent. I always find that expression a little tiny bit confusing. We're talking about interest rate and then we're talking about basis points. Why don't we just talk about hundredths of a percentage point? But in the finance world, sounds fancier, talk about basis points. 7 basis points above the 4%. To illustrate what happens when these numbers get big, let's put that up to 18%. Right. Now, 18% is hurting, right? Well, remember, down around 2, 3, 4%, the interest rate isn't really that huge kind of a burden on you. You're not losing your pants as a result of, or your shirt as a result of paying interest. Whereas when you're getting up certainly over 10%, you know, the interest is starting to be a really significant hit. Okay, and every extra bit of interest is even harder to handle. Here, the difference between the apparent rate, the stated rate, 18%, and the 19.5%, that's 1.5%. You say, oh, 1.5%, you know, small sort of saying that 1.5%, 2% is not really a big deal. But when it's 1.5% on top of a very high level of interest, then it hurts. Right? Let's do it on 24%. Okay, and now at 24%, the effective annual rate is now an extra 2.8% above. And if we had our recurrence interval, let's say at 52, so we're doing weekly. Weekly, by the way, is actually 52.2. At school, you would have learned, you know, there are 52 weeks in the year. That's about right there. That's the whole number. But if you actually divide 365 and a quarter by 7, you end up a lot closer to 52.2. We'll put that in. Well, let's just look at whatever difference it makes now. Just watch what happens to the effective annual rate when we go to weekly. Okay, it's actually added a bit, hasn't it? Okay, that's added, and we'll go back to 12. Okay. Added, you know, another fraction of a percent just by changing the recurrence interval. So you've got to be wary of all that sort of stuff. Okay, by all means, commit that equation to memory, or, you know, say, yeah, on occasions I'll be able to pull that one out. That's not such an important one, by the way. And so you'll find, some financial calculators may calculate it for you with a built-in function, but others will say, well, if you're interested in that, work it out. You know, it's not a hard equation. Away we go. Okay, effective annual interest rate. Da-de-da-de-da. Now we get on to bonds, and that's fantastic, because I think we've done something pretty interesting today. We've built a nice amortization schedule. We've looked at the way that bonds worked. We've worked out the payments. We've introduced the Excel payment function. By the way, the Excel annuity functions all have this kind of form to them, and we'll see that as we go along and do other exercises. But you can see how that kind of works now. And we've even done a couple of extra things for the people who are really keen. Built this little chart and so on to demonstrate the effects of different interest rates and stuff. And so that's kind of given us a bit of background as well. At this point, we'll take a break. I think you've all been wonderfully behaved, because nobody has kind of burst in. I can't even see anyone, I don't think. Everyone's turned off their pictures. Yep. Now, what we will do, though, we'll take a break. We'll come back at 2:10 and we'll talk about bonds. So away you go, grab a coffee, go for a walk, talk to somebody, whatever you want to do. And we'll see you back at about 2:10. And okay, so now we're recording again. Okay, before the break, we had a bit of a look at basic debt, especially the mortgage type of debt, the principal and interest, sometimes referred to as a credit foncia loan. Just a bit of terminology. You'll find that as you go through finance, there are lots and lots of different words for the same thing. I think every second finance person wants to sound sort of smarter and more involved than, you know, the one before, so they make up a new word for pretty much the same thing. And you'll find that along the way. With the term loans, the idea of a principal and interest repayment loan is a credit foncia. That's one of the names for it. Another type of loan, if you like, is a loan which never actually gets paid back. And there are a number of other variants, if you like. They're very common in the real estate world. A common form is one where you don't pay the principal back at all. but you simply pay the interest. It's simply called, very creatively, an interest-only loan. And so your payments every period, every month or what have you, is nothing more than the interest. Let's put our share back up, share screen 2, share, and hopefully you're seeing screen 2 now. So if you're not, someone just open your microphone and tell me. I'll just show you what happens if we had an interest-only loan here. What we're going to do is take the interest cost there, and we're going to make, just want to make sure when I do this I don't mess up the math through it, because I want to undo this after I finish showing it. Equals that one there, interest-only loan. Okay, the payment every month is exactly the interest cost for the month, and so it just keeps the principal exactly the same. You'll notice that the numbers here on our repayment schedule are deadly boring, and here you'll notice the repayment principal versus time remains absolutely dead flat. And if we were to go down 25 years later or whatever it is, we're still going to be owing the $100,000. That's a principal and interest loan. That's one variant. I think if I fill these back up, I fix all that. Okay, so that's back to our regular loan. And the other type of loan, which is common, so we've got credit foncia, principal and interest. We've got a interest-only loan. The other one is a critter, not so common for long-term, but it is used, especially for short-term project finance, such as property development finance, is a capitalizing interest. Capitalizing interest is where the interest cost per period, per month say, is added into the capital value, added into the principal. That's where you pay no payment at all. Very handy if you're a developer and you don't have any funds. Intermediate funds while you're digging roads or building tall buildings or whatever you're going to be doing. You don't have the money to go and make those intermediate repayments. That's very awkward. So you simply capitalize the interest. And there, notice what's happening here. We'll just make this graph a bit taller so you can see what's going on here. Now, the important thing, it actually doesn't start from 0. You guys might want to give some thought. What does it actually start from? What's the number this starts from? Well, it's $100,000, isn't it? Okay, that first number up here. But with the compounding effect over the 300 months, 25 years later, we now owe over $40 million. That's a 24%. If we make that a little bit more modest, it'll be likewise the compounding effect, the interest on interest effect is a little bit more modest. But we're still going from $100,000 to well over $250,000 over the 25 years, even with a very marginal rate of interest. So we take interest rates up to what they have been for most of the last 20 years, we'll say 6%. We'll see there'll be a little bit more of a bow in that number, and the top number here will be a bit higher, right? Last example, when we had 4% interest, we got up to a bit over $250,000, so the number was sort of around there. Now, an extra 2% over that same period of time has caused the growth in the principal to now go up to what, over $450,000. So that's about an extra $200,000 as a result of that 2%. Okay, that is the capitalizing interest. Very useful for very short-term projects where you don't have much cash flow available. And again, I'll just fix that up in my model. So we're back to where we started. Okay, we don't really want to talk about that anymore. We want to go on and talk about bonds. Okay, capitalizing interest is probably a good way to start talking about bonds. You use capitalizing interest for situations where you need money for a short bit of time. You want to borrow it rather than get it as equity. And you're going to be paying it off in a different way. And now we have the notion of bonds. When you lend to a company, the common form of loan into the company is a bond, sometimes called a debenture. And a bond is And I'll see if I can model this. It's a type of loan where I'm going to do this like across horizontally, right? I'm going to do 0, 1, 2, and then I'll do a bit of laziness across here, and I'll put that in over 10 years, right? Over 10 years. What happens is that the bond is structured like this. The bond might say that in 10 years' time, we're going to give you $1,000. Not a nice number. That's probably a little bit easier than using $1 million, but we can use $1 million or 100,000 or any number that we like. Or we'll get $100. Actually, 100 might even be better for our purposes, because often debentures, or at least used to be, commonly denominated in $100 units. Okay, so the deal is, how much would you pay today for something which is going to give you $100 at the end of the 10th year? Okay, well, you guys now are starting to think in terms of time value of money and all that sort of carry on. So already you're starting to think, well, what rate of interest would I like on that? Let's put a rate. Put in a number 5%. Okay, and we're going to apply our same conventions here. We're going to use blue, come on, blue there, blue there for our data. Got it? Okay. And by using our time value of money, we could say that $100 in 10 years' time, and I'll add a couple of things here. Put term, so use the same term. So it's a 10-year bond. Okay, and I want to work out the PV. Here's the FV. Okay, we've got $100. So the business is saying we want some money to build up our business. And the way we're going to deal with it is we're going to pay you back $100 in 10 years' time. And they then add in the paper, or actually they do a little bit more elaborate than that, I'll issue some sort of a prospectus or whatever, and they'll go to the market and they'll get the market to say how much money the market is going to pay for the right to receive $100 in 10 years' time. Okay, if we're using annual stops, so current interval of 1, won't worry about using that just yet. We can now work out what that is. We're going to use an Excel function here. This kind of a calculation, by the way, normally I would just do, not mentally, but you'd use it using regular algebra rather than using Excel function. But because we're kind of getting into using the Excel functions, we may as well put it in. Okay, we're going to use the PV function here. Before the break, we were using the PMT function. You'll notice the format is kind of the same. Here I'm saying equals PV, because that's what I want to calculate, open brackets. Excel gives me this little cheat line here. It tells me what parameters I need to put in, including the optional ones. And I just basically pack those in, close the brackets, and Excel does the rest. Okay. Same format. Rate. Okay, rate is 5%. Yeah, we'll put it in without recurrence interval for the moment. Number of periods, going to be 10 years. Payment. I'll do this in a slightly different way. I'll say payment's going to be $100. No, sorry. There's no payment, is there? Notice I'm going to do a little trick thing here. See there's a comma there just before the cursor is flashing. I'm going to put a second comma in. Watch what happens down here on the cheat line. Okay. What Excel has said, okay, Small's put in 2 commas in a row. It means that he's skipping the PMT entry. In this case, we don't actually need it because we don't have payments, intermediate payments. And we're going straight to the FV. And the FV is going to be the L12, so it's that fella there, $100. And because I want this number to come up as a positive, I'm going to put the payment. Oh no, I won't worry. I'll put in the payment as a negative. Won't worry about the type. Okay, I'll hit return, and guess what happens? It's going to be a negative answer. Okay, negative, and it's defaulting, giving me pounds. Okay, what's that saying is that if I want a cash inflow of $100 in 10 years' time, if the market is expecting an interest rate of 5%, I would be prepared in an efficient market to pay $61.39 for that. So paying out of my pocket, -9, minus sign. Now, that's the hardcore maths way of doing it. But because I want to keep unnecessary negative signs off my model, I'm going to negate that function by putting a minus sign. I'm going to put that in at the front there. And so now the payment, the PV, is calculated, so it's in black font, and the minus there is gone because I put the minus inside the equation. If you want to think about why that works, go for it. You'll just find it's nice having minus signs. As a convention, by the way, we've talked about a few conventions I use. I use the blue font for data. The other thing that I do is that where a number is always going to be negative, I will tend to take the negative sign out just to declutter the model. Where the number is sometimes positive and sometimes negative, for instance, cash flow for tax. Most of the time you're paying tax, so it's a negative number. Sometimes you might get a tax rebate or a tax refund, so it's cash coming in. There, it's important to have the sign on there because in your model, those kind of numbers might be positive, sometimes might be negative. Interest costs are always negative. So you just put it into the equations and you don't put zillions of minus signs all over your model. It just looks messy and it invites mistakes, and we don't want mistakes. Okay, we've just valued a bond. And we've used, in this case, the built-in Excel function. You guys, a lot of you have probably already done that. You know, get your Excel model sort of humming along. Get that $61.39 worked out yourself. If you want to do that on a financial calculator, I really encourage you, if you've got your 12C sitting at your side trustily, enter the data that we know, interest and term, FV, calculate for PV, bingo. Okay, that's kind of fairly easy. That's a very simple bond. It's odd because most people think of the relationship, the contract is written the other way. Most people think, well, if the company wants to borrow $100, why don't they borrow $100 and pay us back $140 or whatever it is that it's going to be? Why is it that they give you this face value thing at the end? Well, I don't know if I've got a really good answer apart from history. That historically, that's just the way that corporations, companies got in the habit of going to the market with this promise of a certain future amount to being paid, and then the market comes back and works out what they're going to pay for it. We refer to that process, by the way, of the market working out what to pay for it, turning the $100 into the $61.39 as discounting. So the bond is discounted. And so by doing that, you work out what the price is. If the investor really wanted 6%, because the way we've set this model up, this will automatically calculate it. And you'll say, if you really wanted 6%, you'd only be willing to pay $55.84 for that bond. On the other hand, if some other investor came along and said, oh, well, I'd be happy with 3%, the bond becomes more valuable. Guess what happens when the investor, for whatever reason, doesn't want any interest at all? You might believe in charging interest. Hang on, better put 0 rather than 100%. What's the number going to be? You know, it's $100. Okay, and basically, the bigger the number here, the smaller the value of the bond. Up to 24%, and you see that we're getting to be pitifully low values here for this 10-year bond with no intermediate payments. Okay, let's go back down to the 5%. Okay, and we're kind of happy with that. Okay, that looks kind of reasonable. Now, that's the face value of the bond. Bonds always, well, almost always have a face value. But as well as that, sometimes I'm going to move this now just up here. Sometimes the bond is written, so they'll say as well as that, they will offer some kind of a payment along the way. These things come with a strange name. It's called a coupon payment. And that goes back to when these bonds were first being written, well before computers, back over a century ago, in the 1800s, or even before. And when you would buy your bond, you buy a $100 bond, right? And it comes as a piece of paper, really special, fancy bit of printing and all that sort of carry on. And it would have these coupons attached to it, these little chits of paper. And every 6 months, typically, or maybe a year, you would take one of these little shits, the little coupons, and you'd go along and you'd go to the company and they would exchange your coupon for so many dollars. And I'm going to call that the coupon rate. Okay, come over here and I'm going to say the coupon rate is 3%. Do that. What does that mean? That at the end of every year, come to it here, equals the face value, absolute it by hitting the F4 key, multiplied by the coupon rate, which I'll also absolute, and so what's happening here is that every year, at the end of every year, I'm going to get one of these coupon payments. What that means is that I pay the $61, but now I'm getting $3 at the end of the first year, $3 at the end of the second year, $3 at the end of the third year, and so on. At the end of the 10th year, I get my last coupon payment, and I get the face value coming back as well. And so here I get $103. That's fantastic. Okay, what's really happening here when you write it up in this form, it looks like an annuity, doesn't it? Okay, those of you, ring bells from a couple of weeks ago when we were looking at annuities, series of regular equal payments over a period of time, and an FV and a PV. That's what we've got here. It's only an annuity. Don't let the complication of we're talking about annuities one year and we're talking 1 week and we're talking about bonds this week. It's all annuities, regular payments with present value and a future value, something like that. Okay. I'm going to come back in here and see what does that do to the value of the bond. Well, you see over this period of time, I've actually received, like I just mentioned, I buy this bond and I pay $61.37 for it. Before the coupons came along, I was going to get $100 in 10 years' time. I had to wait for a long time with that, and sort of value of money's going down. That's no good. Now I'm getting $3, year on year, as well as a little tiny bit of a sweetener. I've actually earned $30 in coupon payments. So obviously my bond, I should be willing to pay more for that. Now let's come back up here in this equation. Remember we forgot or we ignored the PMT function. When we first wrote this equation, we just put 2 commas in there because we didn't have the payment worked out. Now we've got a payment. We're calling it a coupon in this particular case, but generically in annuity world, the coupon is just the payment of this particular type of debt annuity. I can take that number from anywhere. I'm going to take it from in there. What that's saying now, what is this equation saying? It's I'm going to take the negation of the PV function in Excel for a rate of 5%, using number of periods, which is the term, and a coupon rate of $3, or coupon payment of $3, and a face value of $100. Hit the go button there. And now I'm willing to pay $84.56. Nice thing about this form of the equation, like all of these models as we build now, we can now sort of play with this and see the sensitivities to different changes. Okay, I'll put the coupon rate down to 0, and we're back to the $61.39. That should not be a surprise. Let's put the coupon rate up to 5%, which just is also the interest rate that's coming there. Watch what happens here. It's really interesting. $100. Okay, and it will always be $100. If this is $5,276.42, the PV, if the coupon rate is worked out at the same interest rate as the market interest rate, then this will also be that same number, and I can't remember what it is. Okay, but we can, do that sort of carry on. Okay, so the coupon is an important part of the game. But before we go any further, it's important for you to start to now calibrate this to the real world. A bond. It's a loan given to a corporation, to some business. It can be a loan given to the government. They all follow this kind of arrangement. A face value that gets repaid at some future point in time, specified as a future point in time, 10 years off, 5 years off, 3 months off, whatever it's going to be. And it may or may not have a coupon payment, which is the fancy name for the annuity intermediate payments through that period. That's all a bond is. All it is, just an application of annuity maths. So, not hard. We've done most of the maths here, or at least we've let Excel do it for us. Away you go, that's the basis of it. Now, I want to point out just a couple of little curiosities about these rates that we've got here. Okay, we've got an interest rate here, and we've got a coupon rate. And down here, we've got a coupon payment. Okay, the coupon rate causes the coupon payment. So the coupon rate is a percentage. Coupon payment is a number of dollars. Okay, so far so good. But look at these two percentages, the interest rate and the coupon rate. Now, this is a bit of concept, a bit of theory, if you like. The origin of those two numbers is totally different. In this case, we've put them together so they're equal, and that gives us the happy result of giving the PV of the whole bond with its coupon payments. It just happens to work out to be the same as its face value. Easy. Okay. Where does the coupon rate come from? It comes from a decision, usually by the board of directors or financial controller or somebody in the organization. They just sit down one day, have a bit of a think, and they say, we will issue coupons with a face value of $100 and a coupon payment of $5 or a coupon rate of such and such a percent. Usually, what is quoted is the coupon payment, not the coupon rate. Doesn't matter a great deal because you can work that out sometimes mentally, but one way or another, the value of the coupon. And so it's the directors of the company, the CEO, the chief financial officer, somebody makes that decision arbitrarily. Sometimes they make it to be close to the market, sometimes they don't. Sometimes they set it at 0, so there's no coupon rate at all. Is there a right or wrong for this? No. There are strategic reasons why a particular coupon payment, rate, whatever, is selected. And it's got to do with the strategy, the financial strategy of the company. In some cases, the company might consider it a sweetener to make it easy to sell the bonds by having those coupon payments. So you've got these nice little, delights coming through the life of the bond. And so they'll put the coupon payments up. So they're kind of pretty close to what the financial controllers of the company think is close to what the market would use to discount the bond. Okay. On other occasions, the company might think, well, we're really hungry for cash, and we're not going to have a lot of cash coming out of what we're doing for a few years. Maybe they're starting a forest. Okay, so you're starting a company which is Pine Incorporated or something, and they want to start a million hectares of pine forest, down through the east coast of New South Wales and Queensland or something. And they've got to wait for 25 years for all these pine trees to come up to the stage where they can be harvested. They don't have any money to pay off a coupon. And so they put 0 coupons on. So it's absolutely not on the market. Okay, so there's this strategy, roughly between what they, one extreme is about what the decision makers are believing to be the interest rate that the market will expect, and the other extreme is nothing at all. And it could be anywhere in between them. Okay. So coupon rate decided by the corporation. The interest rate here, and I'll give this a different name. I'm going to call this the yield rate. Can't type anymore. Yield rate. Okay. That's what the market thinks would be fair. Right now, for those of you, and I do encourage you, by the way, by about this point in the course, start taking a bit of an interest in the financial literature. Read articles on the financial situation in the world, from the major media outlets. Maybe start to look at the Reserve Bank of Australia and their comments, and their newsletters, stuff like that. Some of you might want to look in on some of the commentaries written by the major banks and financial institutions. Westpac is very good. AMP has an excellent economist who does some really gold-plated commentaries on where the economy is going. RBA, likewise. Okay, start doing that, because it's a good way of actually calibrating your interest and really making this stuff kind of, relevant. Okay, but one way or another, if you were thinking about buying a bond, you've got, a few dollars left lying around, maybe your, rich uncle sort of leaves you $1 million or something, and you think, oh, well, I'll buy bonds. Terrific idea. Okay. You'll have to make some decisions, and you have to have a few ideas of what's going on there. And one of the things is what rate is the market expecting? What is the yield that people are expecting on bonds? And that's pretty much what we're using here. Do we know exactly what that is? No, not really, because we'll only know that at the end of the 10 years when the thing is totally finished and paid off, right? Now, that's what the actual historical market is. But what's happening is that this, at least at the beginning, is more like a guess. It's the guess that the market says for this type of a company, in this part of history, 5% is about what people would expect to be getting on a bond. Now, if it was a mining company, maybe a gold exploring company, this number could be quite high. It might be up to 12%, might even be higher. If it was something that was really sort of staid and stodgy and, almost guaranteed to earn a quid, tip-top bakeries, something like that, the number might be down around 4%. Okay. I'm not sure what that is at the moment. I haven't sort of checked before I came into class, so I wouldn't want to say bad things about tip-top bakeries or whatever. But basically, the more secure a company is, more reliable, the lower the number's going to be, because people are happy to get a nice, secure repayment. Then, whereas if they're going to be taking a bet on some gold mining explorer sort of out the back of the Northern Territory somewhere, they're going to be thinking, wow, I might make $1 million here, but I could lose my money as well. And so they're expecting a high yield on bonds to some dodgy company, whereas a nice, reliable company, Toyota Australia or something, they'd likely be a lower number. We'll put in 6. Okay. And as we've written the model, you can see here that the numbers are changing as we go. It's interesting here. Oh, that's right. Yeah, our coupons are going separately. Right. Okay, so far so good. We've said that the coupons tend to be paid twice. I'm not going to do other recurrence rates because it's just a little bit awkward to model, but you can do that in your own time, right? If we had 2 payments a year, 2 coupon payments, and I say debentures, bonds are commonly paid twice annually, biannually. To make my 10-year model here work, I'd have to sort of spin it out for 20 periods, and it's just a little bit tedious to do. We could do that, and we could even automate it, but it just it's a level beyond what we can do in the time that we have available. I want to get on and talk about other things. Okay. Right, so what have we said? We've said the yield is the number that comes from the market's guess of what they would want as a rate of return into the future. Their yield, it's their guess, right? So the payment which is made here is based on this guess. Let's look at it a different way. Let's look at a situation where you are thinking about buying bonds. And maybe we've got these bonds with this particular coupon structure. And you look down at the exchange, where the bond market is, and you can see that there are lots of these in the market. Might be some big company. And rain, hail or shine, if you're going to buy a bond there, you'll have to pay $98.23. Now that's the practical reality. You don't get to go along down to the company, BHP or something, and say, you know, Mr. BHP, I want to buy one of your $100 bonds with a $5 coupon on it, 10-year bond, and I'm going to pay you $62. Doesn't happen. Right? There's lots of buyers, and Mr. BHP knows that you know, his company has a particular quality, particular risk profile, and so he simply wouldn't sell it to you. Right? He'd say, yeah, if you want to buy one of my bonds, go for it. I'm really glad if you do, but I'm going to charge you $98.23. Okay. What's going on here? Well, we don't have the control to set the price. We're taking the price which is offered. What's the variable? We're certainly going to get $100 in 10 years' time. We're certain that the bond is written with a $5 coupon rate. What's the variable? Still going to be 10 years. Still run recurrence, like it's annual payments. The variable, oh, and even the coupon rate's not going to change because the bond is actually written. It's going to be paying me $5 at the end of every year for the next 10 years. The only thing which is varying, take that one out for the moment, is this fellow, isn't it? So I can say, oh, okay. If I'm going to get this bond, I have to pay $98 for it. What does that mean I'm actually making out of it? I'd like 6%. I have to pay too much money for it. How much? How hard is the thing going to work for me? I want to work out the yield, don't I? Okay. So if this is the data, put that in bold to make it a little bit more obvious. So here we've got the, that's the payment that's actually going to cost me. And I want to work out the yield. And this is a total yield over the whole thing. And I'm going to call this the yield to maturity, YTM. I'll actually write that long term. And by the way, you guys who've got your Excel open, by all means, follow me, right? Just you won't have to put all the words in if you don't want to, but certainly put in the calcs because it'll really help you to get your Excel skills up, and that'll help you doing assignments and doing exam, and you know, when you calculate this stuff 20 years time when you're working in professional practice. Okay, yield to maturity. I want to work out, if I have to pay, I don't want to pay it, but I have to pay $98.23. What is the effective yield on this thing? Now, remember, it's nothing more than an annuity. I've got the FE, I've got the payment, I've got the term, I don't have the I. I don't know what the interest rate is. Okay. What's the answer, they say? Well, isn't Mr. Excel nice to us? So far, Mr. Excel has come to the rescue. And it's given us functions for anything that we might know about. We want to find the rate, don't we, using Excel speak? So there you go, rate function. Start writing that up. It gives me a little cheat line there. It says the first thing that I want here, the first parameter is the number of periods. So I'll put that in as 10 years. Put in a comma. Next thing it wants is the payment, which is going to be it's going to be $5. It's asking me for the PV. Now the PV, now here I'm going to go back to using the sign convention, because remember I have to balance the dollars coming in, dollars coming out. So here I'm going to be very, very shrewd, very careful indeed with the minus signs. So I'm going to apply the basic signing convention, which is dollars coming into my pocket is positive, dollars going out of my pocket is negative. So the payment is coming into my pocket, so it's positive. I'm up to the PV. Notice PV is highlighted here. That's going out of my pocket. I have to pay it, right? So I'm going to put that in as negative. Minus that cell there, market payment, comma. Now for the FV. The FV is going to come into my pocket. It's going to be $100. Don't worry about the type or the guess. Close brackets. 5%. Okay. So if I could get 6% exactly, I'd only pay $92.64. Here I have to pay $98.23. And so Excel is telling me that means I'm effectively getting a yield to maturity of 5%. I'm going to put a couple of extra decimal places in there to actually see exactly what it is. If I put even more decimal places, I'll get more of them, but really 2 decimal places of a percent is about as far as you need to go. Okay. Yield to maturity. Very important, because now that tells me what the bond is doing for me, right? If I had to pay $100 for it, I'm getting 5%. If I get it for $50, I'm getting a really fancy result. Typically, that'd be a very high risk bond that would come with a fancy yield to maturity like that. Okay, and what we were talking about was $98? You know, away you go. Okay, building the models like this, you see, you can play with them and just see what these things do, and that is really, really handy for you to get your head around what's really going on too, especially when we get to strategies and stuff like that. So I do recommend you do that, but also you practice with your financial calculators. I mean, you've done this model perhaps, then get out your financial calculator if you're using a financial calculator, and actually sort of do all of these sums, all these computations on your financial calculator, so you see the financial calculator, you should get exactly the same results as well. Okay, fantastic. Okay, bonds. Okay, we've got some introductions there. We've talked about coupon rates. We've talked about zero coupon bonds. Well, that's the one that doesn't have a coupon payment. Convertible bonds we ought to talk about. I think if you read through, you'll find that, I'll go back here. Convertible bonds are loans that you make to the company, but with a sweetener, a little extra element, that if you buy the bond, might be over 10 years, you actually have the advantage or the option, the right but not the responsibility, to turn your compound, excuse us. Where were we? Convertible. You have the right but not the obligation to convert your loan to the corporation into shares in the corporation. So you go from debt to equity. And I'm talking about debt and equity more in detail a bit later on, but it's important at this point, at least to know you can do that. So you might sort of pay your $98 or what have you and buy your bond. And you think, oh, that's really good. I'm really safe because in 10 years' time, I'm going to be getting the $100 back. Rain, hail, or shine. I'm going to be, I've got very good security there. I'm going to be getting the $5 per year over the next 10 years. So that's kind of really nice. But then 5 years down the track, let's imagine the company is fabulously successful. And the share prices are going up and up and up and up and up. And you're thinking, whoa, I wish I'd bought a share in this company rather than a bond way back when I first bought this 10-year bond. You're kicking yourself. Right? You'd only be kicking yourself if you didn't have a convertible bond. Because a convertible bond typically has a provision that says, if you want, under certain conditions, right, you can't do it forever, you can tell the company that you would like your bond paid out as shares. And usually a convertible bond will have a conversion rate, a number of shares or a share price built into the conversion clauses. Okay, and that means that if the company does go gangbusters and the share price goes through the roof, you've actually got a guaranteed price that you can buy the shares for, which could well be very cheap by the time it happens, right? Typically, the conversion is around 15 it expects a growth in the share price of around 15 to 20% in order to make the call on the option attractive. And so I might buy the $100 bond today, and the share price might be $40. And the call price is that I can convert my bonds to shares at the rate of $50 for every share. So in other words, the share price of $50. So if the share price is right now $40, so I prefer my bond. But if the share price then goes up to $60, but I can convert my bonds at the rate of $50 a share, I'm actually getting a $60 bond for a $60 share, sorry, for $50. So it's pretty attractive. And so I might want to convert. Okay. The really lovely thing is that for selling bonds like that, it becomes a real incentive because the bondholder has really got two ways of making money. If the company goes well, they turn into shares. If the company goes badly, they just stay with their bonds and got their security. And we'll talk about that a little bit more later on. Okay, but it's important to know about those. I'll let you read through these. There's examples there. It's basically annuities, right? It's not hard. Coupon bonds, we've talked about that, talked about now bond valuation. Yeah, by all means go through the formulas. Some of you that might scare you a little bit, so just come back to what we've been doing with Excel or practicing with the financial calculator, and that hopefully will make a lot of this stuff transparent. Work through the algebra and so on if you like, so I can kind of do through all that. Coupon bonds, so we're doing all that. Bond valuation. Now I've actually done this. We've dealt with this situation. If the coupon rate is equal to the market rate, remember, the bond will sell for the share price to its face value and so on. That's called a par bond. Okay, and then we've got these other options, discounted bonds, we've got premium bonds, where you actually pay more than $100 to go and buy the bond. And you can sort of see as you juggle the interest rates, and I invite you to build a model and then juggle the interest rates and just sort of see how these things come out. I find it really interesting to do that for yourself. So if I just show it to you, you'll go to sleep, right? But if you do it yourself, you think, whoa, if I get onto this and actually sort of spend my, Christmas savings or something on buying a couple of these $100 bonds, well, it's fun. And you get rich. Okay, zero coupon bonds we've talked about. Bond yields we've actually sort of talked about, and you might want to go through that. Now that's the math. That's the classic way of doing it. It's really written from the point of view of using a financial calculator, the standard scientific calculator to work these stuff out. Work through that if you're interested with the maths, but I've shown you how to do it with Excel. There's one little wrinkle here. We're using the same slides as we're using pre-COVID because we're doing take-home exam. This comment here down on slide 57, if you download the slides yourself, and I really want you to do that, get down to slide 57 and gives you a little bit of a hint about the exam. Don't pay any attention to it because while we're not doing formal exams, the exam may get you to focus on yield to maturity for non-zero coupon bonds. And the reason is I've just shown you how to do it, and it's very easy. So I'd like you to be able to, do that in the exam if necessary. Right, so make sure you ignore that because I don't want people coming along to me night before the exam saying, oh, yeah, you said that, da-da-da-da-da. And I'm saying, no, here we are on the 4th of August, and I'm saying, do it with Excel, do it with your financial calculator, but be able to do non-zero bonds. You'll find that the some of these functions you can do with a scientific calculator. Some of them can only be done with either Excel or a financial calculator. Right? And as you read through the notes in detail, you'll see those. Okay, then we get to realized bonds. Now, to understand some of the extra complexities with bonds, it comes down to terminology. Once you unpack it and see these things just in terms of a series of cash flows, which is one of the reasons I kind of just laid these out on the model here, year by year, right? Is that sometimes people will not hold the bond for the full 10 years. They buy a 10-year bond, which means that in 10 years' time, they can get the $100 out. What happens if they choose to sell it at year 6? Right? They might need the money. You know, daughter might get married or something, and all of a sudden you need a big wad of cash to go and, you know, walk it down the aisle. Okay, you have this 10-year bond, it's only halfway through its period of maturity, and you sell it. What's going to happen there? Okay, now I'm not going to model this because we don't have time now, but I think you can imagine that the market will be looking at this situation and they'll say, okay, then this is the ragged bit, the leftover bit of the bond, right? I want to sell it. Maybe the $5 has just been paid, right? So they've all been paid and gone. Might grey them out a bit. And you're going to the market to sell this thing that now we're looking at this point here as the beginning, and somebody buying it is going to be looking at a 4-year bond, aren't they? And in 4 years' time, they get $100. And at the end of every year, until then, they're going to get $5. And they're going to say, well, what is the value to me of this bond right now? They'll get into their Excel spreadsheet or pull out their financial calculator, and they'll say equals PV, the rate, the market rate they're expecting there is this fellow. The number of periods now is 4. The payment is $5. We'll put it in minus $5, show that works. And the future value is minus 100, da-da-da-da-da. And so at that point, somebody will be willing, assuming they're happy with a 6% return, 6% yield, they'll be willing to pay $96.53 for that bond, right? And so you're happy, you get the $96, you go and buy a bit of confetti with it for your daughter, and everybody's happy. Somebody's got this new bond, you've got the $96, and you want to ask the question now, if I got that $96, I'm going to put the $96 in here, and I'll even put it in as blue, right? Let's imagine that I paid $98 for it down here in year 0. I got my 55555, and I sold it for $96. Okay, let's say I've sold for maturity. I've purchased it, and I'll just put in a number there in blue. Sold. Sale price. I'm actually going to bring this number down here. And I'll say that equals 98. Oh. And I'll put in a couple of those. Okay, sold before maturity. Okay, so I bought it for 98. I'm going to, the market is willing to buy it off me for $96.53 in the end of year 6. Okay, now I want the realized yield. What's happening there? As I'm saying, even though I bought it on the basis of 5.26%, and then I sold it to somebody for that particular price. They were buying it at the expectation of 6%. What yield did I actually earn from it in the time that I had it? That's a pretty interesting question. So now I'm going to solve for the rate. Okay, number of periods, in this case it's going to be 6. The payment is 5. The present value is minus the purchase price. The future value is the future value, is the payment, what I've got for selling it. Okay, so I've got, now watch what happens here with this number. This is a fabulously interesting number. Hang on, I won't put, no. I'll put it in as green because it's an interesting number, and I want you to watch this space, and we'll do this and then we'll finish up, and I'll let you read the rest of the notes in your own time. So I know I'm running a little bit over time, so I hope I've still got your attention. Okay. So before maturity, I bought it expecting 5.26% to maturity. I chose to sell it to a purchaser a few years off who bought it on the basis of 6%, which meant that instead of getting my 5.26 I was expecting, I'm actually getting a bit less. I'm only getting the 4.88. That's what happens if the interest rates do different things over time, because we don't know what the interest rates are going to be doing over time, right? I guessed, and I was happy to buy it in the first place with a yield to maturity of 5.26%. But the economy could have been getting stronger through a few years, and maybe the expectation of interest rates was going up. Maybe the economy was getting weaker, or maybe around here people were thinking we're going to have a recession. And for each one of those scenarios, the people engaging in the market are setting the rate that they think is fair. You had to buy it on $98 with a yield maturity of 5.26%. You were happy to do it. You did it freely. That was your choice, right? So you accepted 5.26%. The market was selling them for 5.26%, so they were happy as well. Okay. But you don't know what the future is. And the way these things wax and wane and what have you is totally the reality of what actually comes out. At every point, you're taking a bet on the future whenever you go into a financial investment. Let's look at what happens if the people here who bought it off you are actually more hungry for a return. Let's imagine they wanted 10%. You still bought it expecting, you still bought it for the $98, so you bought it expecting 5.26 over the life of the loan. But by the time we get up here, for whatever reason, the market now is hungry for a higher rate. So they won't buy it off you unless you give them that higher number, all right? But what it's done is that instead of the 5.26 you're expecting, your realised yield has kind of been eaten away to almost nothing. On the other hand, if this was the heady days of, you know, the late teen 2000s, 2015, 16, 17, 18, okay, a 10-year bond might have come in expecting a higher rate. So this might have come in at $90. So you might have been expecting 6.38%. That's how you bought it. And then by the time you get up here and sell it to finance your wedding or whatever it's going to be, the interest rates, COVID had come along, and now the market is going, whoa, we're all going to die. So they're happy with a 3%, or maybe even a 2%. Right, what happens here? Now, you know, in the COVID world, a $5 coupon rate is looking really fancy because everyone's saying, well, all these businesses are going to go to the wall. So nobody's giving $5 coupon rates anymore. They might only be $1 or $2 at the best, right? So that's looking pretty smart. And we've got the $100 coming up. So they're actually going to be buying it at a premium above the face value. Means fantastic for you because you bought it expecting 6.38%. But in fact, your realised yield, because of COVID, is you've actually come in on, a substantially higher rate of return. So you get wealthy because everyone else is going to die of COVID. Fantastic. Okay. Every cloud has a silver lining. Okay. So in this form, and admittedly, I've done this in a little tiny bit of a hurry, so you might want to give that a bit of thought and maybe play over the video for this a bit and then go and play with it. But what it does is that it explains to you how risk in the market works and also how the term expectations, the expectations over the term, kind of really determine the intermediate values and then some of the strategies and some of the outcomes that can come from it. And with that, I recommend that you read the remainder of these slides, especially these fellows down the bottom. We talk about market efficiency. I would have liked to have spoken about market efficiency a little bit further on. We might come back to that later on. It pretty much speaks for itself, though. It's really only definitions at this stage. Real rate, expected rate. Oh, we might even spend a little bit of time looking at some of these slides next week, but I won't spend any more time on it now because we really are out of time. Thank you very much for your attention. I will finish the sharing.
Excuse me.
Yes, sir.
Actually, I was asking that when are we going to get our assessment 1?
That's a good point. I should have it to you very shortly. I may, I've had a couple of complications that have slowed me down sending it out to you. I'll aim to have it available at the end of the week, and I'll give some thought. We may extend the solution time for you.
Okay, thank you.
Oh,
Yes,
sorry. Care, could you please upload this document, Excel document to the model, please?
Say again, please.
Could you please upload this Excel document to the model?
Yeah, sure. That's a good idea. We've done some interesting work here. I would really like you guys to build your own, though. Okay, I'm happy to upload it. But for those of you who say, oh, fantastic, got Small's model, that'll be terrific. Yeah, it will be, except you won't learn as much. So make sure you do it as well. That's the only caveat I'd put on, right? So I will upload that. That's a good idea. I'm happy with that.
Thank you.
Thanks, Sharon. Any other questions, suggestions? No. Okay. Thanks for that, and thanks for those questions and suggestions. That's really useful. I'll get that going. Now, I'll be uploading that probably tomorrow afternoon after I do the Wednesday class, because otherwise it'll be sort of taking a little bit of the wind out of the sails. The other thing that I'm looking at doing now is that I'll probably put up one recording every week, and it won't necessarily be for this class. Sometimes I'll put up the Wednesday's class, sometimes I'll put up the Tuesday's class, sometimes I'll put up both of them. I don't think it's necessary to put up both of them, just that sometimes as the classes go, one class flows along more effectively than the other, and so I'm, I really can't say which one's going to go better at this stage, but I'll put those up tomorrow afternoon, and I'll get the assignment up for you, and I'll put a model. Now I'll be writing another one of these tomorrow for the other class, so and it may look a little bit different because I might put stuff in a slightly different order, right? But I'll put up the model which goes with whatever is. I'll put up both. Okay, I'll let you go now unless there's any other questions. Thanks very much for your attention. I hope you enjoyed the class, and I hope you learned a bit. Bye-bye.
Thank you. Bye.
Thanks.